We have a semicircle with center O and diameter 4 units. And inside this semicircle, we have a rectangle PQRS. The point Q lies on the diameter, while the points P, N, and R lie on the semicircle, with N lying on side P, S of the rectangle. We are told that Pn equals Ns, and Ns also equals SR. Our goal is to find the area of the shaded region, which is the rectangle PQRS. There is no need for a calculator here, because everything will work out exactly. So let's introduce one variable to represent those equal lengths. Since Pn equals Ns equals SR, I'll call each of them. Therefore, Pn equals X, Ns equals X, and SR equals X. Now notice something important about the entire side. Point N lies between P and S, so the full length PS is made up of Pn plus Ns. Since each of those pieces has length X, we get PS equals X plus X, which gives us 2X. So one side of our rectangle has length 2x. Since PQRS is a rectangle, opposite sides are equal. Therefore, side QR also has length 2x. The other pair of opposite sides, PQ and SR, each have length x. So the dimensions of our rectangle are 2x by x. That means we can already write down the area formula. Remember, the area of a rectangle is its length multiplied by its width. Therefore, the area of the shaded region is 2x multiplied by x, which gives us 2x squared. So from this point onward, we do not actually need to find x itself. We only need to determine x squared. Once we know x squared, we can multiply it by 2 and immediately obtain the area. Now let's turn our attention to the semicircle. We are told that the diameter is 4 units. The radius is always half of the diameter, so the radius is 4 divided by 2, which equals 2 units. Since O is the center of the semicircle and P and R lie on the semicircle, OP and OR are both radii. Therefore, OP equals OR equals 2 units. Now, we need to take a closer look at the little triangle formed by N, S, and R. Because PQRS is a rectangle, every interior angle of the rectangle is a right angle. In particular, the angle NSR is 90 degrees, because NS lies along the same line as PS, and SR is the adjacent side of the rectangle. We also know that NS equals SR, because both of them were defined to have length X. So, triangle NSR is a right isosceles triangle. This is extremely useful because the two acute angles of a right isosceles triangle are equal. We already have one angle of 90 degrees, so the other two angles together must total 90 degrees. Since they are equal, each one must be 45 degrees. Therefore, the angle S and R is 45 degrees. Now pay attention to what happens because P, N, and S are all on the same straight line. The ray NP points in the direction opposite to the ray NS. So the angle PNR and the angle SNR form a straight angle. We know the straight angle is 180 degrees, and we just found that angle SNR is 45 degrees. Therefore, angle PNR equals 180 degrees minus 45 degrees, which gives 135 degrees. This is the key angle that connects our rectangle to the semicircle. Notice that P, N, and R are all points on the semicircle. Therefore, angle PN NR is an inscribed angle of the circle, and it subtends chord PR. We can now bring in the central angle theorem. The central angle standing on the same chord is twice the inscribed angle. Since our inscribed angle is 135 degrees, twice 135 degrees gives 270 degrees. So, the reflex central angle POR is 270 degrees, but we are interested in the smaller angle at the center. A complete turn around the center is 360 degrees. Therefore, the smaller angle POR is 360 degrees minus 270 degrees, which equals 90 degrees. So, we have reached a very useful result. Angle POR is 90 degrees. Now look at triangle POR. OP and OR are both radii, and we already know that each radius has length 2. We have also just established that the angle between them is 90 degrees. That means triangle POR is a right triangle with legs of length 2 and 2, and its hypotenuse is PR. So now we can use the Pythagorean theorem. Remember, the Pythagorean theorem tells us that in a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. Therefore, we have 2 squared plus 2 squared equals PR squared. 2 squared is 4, and another 2 squared is another 4. So we get 4 plus 4 equals PR squared. That gives us 8 equals PR squared. Therefore, PR squared equals 8. If we wanted the actual length of PR, we could take the square root of both sides, giving PR equals the square root of 8. The square root of 8 can be simplified because 8 is 4 multiplied by 2, so PR equals 2 times the square root of 2. But notice that for our area calculation, we actually do not need the unsquared value. We already know that PR squared equals 8, and that will make the next step much easier. Now, let's connect this result back to the rectangle. P and R are opposite vertices of the rectangle, so PR is the diagonal of the rectangle. We already determined the 2 side lengths of the rectangle. One side is PS, which equals 2x, and the other side is SR, which equals... Therefore, if we apply the Pythagorean theorem to the rectangle, the diagonal squared must equal the square of the length plus the square of the width. So we have PR squared equals 2x whole squared plus x squared. From our semicircle calculation, we know that PR squared equals 8. So now we substitute that value. We get 8 equals 2x whole squared plus x squared. Let's simplify this carefully. 2x whole squared means 2x multiplied by 2x. Multiplying those factors gives 4x squared. Therefore, our equation becomes 8 equals 4, x squared plus x squared. Now, we combine the like terms. 4 x squared plus 1x squared gives 5x squared. So we have 8 equals 5x squared. Our goal is to isolate x squared, so we divide both sides by 5. This gives x squared equals 8 divided by 5. That is exactly the value we needed. Now, let's return to the area of the shaded region. At the very beginning, we established that the area is 2x squared. We have just found that x squared equals 8 divided by 5. So substitute that value into the area formula. The area equals 2 multiplied by 8 divided by 5. Multiplying 2 by 8 gives 16. So the area equals 16 divided by 5 square units. If we convert that fraction into a decimal, 16 divided by 5 equals 3.2. Therefore, the area of the shaded region is 3.2 square units. And notice how every part of the problem had a purpose. The equal lengths allowed us to express the rectangle's dimensions using x. The diameter gave us the radius of 2. The right isosceles triangle gave us the 45-degree angle. That 45-degree angle led to the 135-degree inscribed angle. The central angle theorem then gave us the 90-degree angle at the center. The Pythagorean theorem gave us the squared diagonal of 8, and applying the same theorem to the rectangle gave us 5. X squared equals 8. Finally, substituting x squared equals 8 divided by 5 into the area formula gave us 16 divided by 5, or 3.2 square units. So the final answer is 3.2 square units. If you found this solution useful, take a moment to like the video, subscribe to the channel, and leave a comment letting me know which step was the most interesting.